Now we're going to make our ladybug interact with the laser. Currently, the laser just shines onto the ladybug and doesn't do anything to them. So let's make a little modification to the laser script so that it can stop a ladybug in its tracks, and then talk about how we can abstract that out a little bit. Let's go into the laser script. And in our laser script right now, we look to see if we've hit a brick. And if we have, we tell it to take damage. Let's add in some code to also hit a ladybug. We'll copy lines 36 through 38 and paste them down below. And I'm going to replace brick with ladybug. We'll copy ladybug over the 3 other instances, including the type here. So lady, I got to spell it out here, bug. B-U-G with a lowercase b. This one needs to be that capital because it's the actual type. Now we've got an error here. It says that ladybug doesn't take laser damage. There's no method on it, so we're going to need to add one to take laser damage. I'm going to hit Alt-Enter and just generate a method. We'll hit F12 and go into that method, and I'm thinking for the ladybug, instead of killing it like the bricks die, I want to make it just freeze the ladybug. So if it hits the ladybug just doesn't move until the laser's off. It just keeps them totally still, and obviously we could easily just change it to do death or something else. But for now, I'm going to say rigid body dot velocity equals vector2 dot 0. I'm going to replace internal with public and then save this off. Now my expectation here is that once the laser hits the ladybug should just stop working, though I don't particularly like the code. And we're going to talk about why that is and talk about how we can improve it in a moment. First though, let's just play and make sure that this is the case, that the ladybug actually stops when it gets hit with the laser. So as soon as we finish reloading, we'll play, we'll run over, turn on that laser, and then make sure that it's updating. Or I said updating, but really it's freezing. Right. All right, any second now it should load up. And we'll go flip on that switch. So our ladybug should be walking back and forth. Turn the switch on. I'm going to kind of jump over here and watch. And look at that, every time it hits the ladybug freezes. So it is working, it's doing the expected thing, but we have a problem here, or at least what I would perceive as a problem. And that's that every time we want to add something new to our laser, we're going to be copying and pasting this code, adding a take laser damage, or maybe some other type of method to this thing so that we can make it deal with laser damage. And I don't particularly like that. I don't want our laser to need to be updated every single time we add something else that needs to take damage from our laser. We shouldn't have to go back in and modify it every time. This is part of that open-closed principle, that our class should be open for extension, but closed for modification, really meaning that if we add new things that interact with and use it, we shouldn't necessarily have to go in and change this class. Now, there might be scenarios where we've done so much where we change it so drastically that we just have to, but most of the time we can avoid this, and we can avoid this by using one of two things, either abstract classes or interfaces. And in this scenario, an interface is probably the perfect option. So we've got this take laser damage method, and both our brick and our ladybug can both implement it. They implement it totally differently, and really all our laser cares about is that the thing that it's hitting can take laser damage. So what we're going to do is add an interface that's common and shared between our brick, ladybug, and anything else that needs to take laser damage, called I take laser damage. Then we can add that on and simplify this code here. So to do that, we're going to go into our ladybug first. And we could do the extract interface option. So if I hit Alt-Enter, I can hit extract interface, and I can choose the members that I want to have. Here there's the the take laser damage is the only public method that we have, so that's the only option available. And the default name for it is iLadybug because it's going to put an I for an interface and the default or the existing class name. I want this to be a take laser damage interface though, so I'm going to make it a little bit more generic by putting I take laser damage here. I'll hit enter, and that's going to generate a new public interface named iTakeLaserDamage with a void takeLaserDamage method. Notice that it doesn't say public here. That's because everything in an interface is going to be public by default instead of private by default, because that's the way interfaces are made to be, the publicly facing interface for this type of thing or this type of object. So now that I have this iTakeLaserDamage, let's go back into our laser. And instead of calling it our code on a ladybug, let's replace this with iTakeLaserDamage. Now I'm going to replace the word ladybug with damageable, or let's say laser damageable. And then we need to also add something on line 40. Because we're using an interface now and not a class, not a specific mono behavior or something that is definitely a class, when we do our null check here, we can't just check it like this. We have to actually say if it is not equal to null instead of if it's true. And that's just because of the way that it does the overloading of that if statement. If you just pass in an object, it will return true if that object exists, and false if that object is null or doesn't exist. But with an interface, that's not the case. We actually need to do the check there. The overload doesn't exist like that. So we'll save, and now I've got a take laser damage method on a laser damageable, but I still have this brick one here, and I want to get rid of the brick part too. So I'm going to select lines 38 through 36 and just delete them. But now my bricks aren't going to take laser damage, and that's because they don't implement the iTakeLaserDamage interface. But I can change that. I can make it so that they do just by copying the interface name. I'm going to save so I can get rid of that star. Go over to our brick, and right after the mono behavior, we're going to add a comma and add in our interface. You may have noticed that on the ladybug, that happened automatically. And what this is telling us that this is a mono behavior as its class, but it implements this iTakeLaserDamage interface. And you might notice in some other code that you write that you can actually have multiple interfaces. I could have an iTakeLaserDamage, iTakeHits from above, or whatever other type of interface that I want to add. That doesn't exist right now, so I'm going to delete it out and save off our ladybug. Now that we've got our ladybug and our brick both taking laser damage or implementing this method or this interface, we should be able to run into Unity and have it work. Now this only works because this method existed and had the exact same name. If this was named like brick take laser damage, then we're going to get an error here. The interface is going to say, hey, brick does not implement the interface member take laser damage, because I renamed it to brick take laser damage. And then I would have to hit Alt Enter, implement the interface down here, and then go put in the code for the method. I don't need to do that though, because I've already implemented it. I just renamed it and broke the name. If I remove that brick word again, just put it back to take laser damage, and that name matches the method in here, it should work. Let's jump into Unity, go play, and see that we get the exact same behavior, but with a little bit less code. And we now have an interface that we can start adding on to other things that we want to deal with lasers. If we got something that we want to warm up or move, or other things that we want to just die or blow up, we can just add that interface and then have them deal with the code however the specific object wants to. So let's go try it out. We'll run over here. We should be able to turn that on. Watch it go. Seems like it works. The bricks blew up and the snail stopped in its tracks. Let's go into Plastic SEM and make sure that we've saved our sandbox scene and say that we added the iTakeLaserDamage interface. And we'll check that in.